All right, so the voltage V of a household current is given by V equals 170 sine of 120 pi t volts, where t is in seconds. Suppose the amount of current passing through an electric blanket is I equals 0.1 sine of 120 pi t amps, where t is in seconds. Find the wattage rating in watts of the blanket. And it tells us there the wattage rating is equal to 1 over the square root of 2 times the maximum P, and where P is equal to V times I. All right, well, we know we're after the wattage rating, right? So that's going to be the last part we're looking at. But it says, because it says it's also 1 equals 1 over the square root of 2 times the maximum P, so I need to know what the maximum P is, don't I?
Just me, or is it like extremely hot in this room?
All right, so we need to find P. And it told us that P is equal to V times I. Well, we know something about V, and we know something about P, don't we? I. So we know P is equal to, what's V? Yeah, right there, isn't it? So the 170 sine of 120 pi t. And what do we know about I? Yeah, 0.1 sine of 120 pi t. And can we multiply those? No, we can't do that. But what we can do, because this is all multiplication, right? This is 170 times sine of this times 0.1 times sine of that, isn't it? So I'm just going to group them here. So I'm going to put my numbers first. So 170 times 0.1, and then my sines. So I have sine of 120 pi t times itself. What does it mean when something is multiplied by itself? It's squared. Good. All right, so when we work this out then, this gives us 17. And sine times sine, we just said, is sine squared. And we can do that since they have the same angle here, okay? Their theta piece is the same. If not, we don't multiply them like that. They're two different functions. They're not the same type, so we can't say that it's squared. Now, I got to figure out something to do with this sine squared. And since it's squared, I'm thinking maybe I need to reduce that power. That would be using one of those power reducing formulas. And so if you look where you have sine squared, well, let me write my P equals 17 times first. Where you have sine squared, it tells you that it is 1 minus cosine of 2 times the angle all over 2. Well, what is my angle here? What is my x in this problem? Yeah, the 120 pi t. And now we just need to work on this. So what do we want to do? How about I can't cancel out the 2 because that's cosine of something. That's part of that function piece, okay? We can't do that. But what I can do is I can say, well, I've got 1 over 2 and minus that cosine part over 2, right? So let's just rewrite what's in parentheses. So this is 17 times 1/2 minus 1/2 cosine of, wait, bless you. Can I multiply these? I don't think I do. Go on to the restroom and grab one. Sorry.
How would that make it 1/2 in front of cosine?
Because what number is right there in front of cosine? A 1, right? So that makes it that 1 over 2.
Oh, you distributed it.
Yeah, I gave it to both pieces, is what I did. All right, now what can we do? Can I distribute the 17? All right, so we got to this point. Now, what are we after with P? What do we need to find that wattage rating? The maximum P, don't we? So when I'm looking for a maximum, what do we usually look at? What's that? Okay, so we're looking for the higher number. What if I looked at the graph? Could I find the maximum on the graph? I could, couldn't I? All right. But another way, so you can graph it, but another thing we can do is just think about this, okay? So think about what we know for cosine. What is the range of cosine? Do you remember? When you graphed it, what was the smallest y value? What was the largest y value? -1 to 1. Remember that when we did our parent tables for cosine? We went from 1, 0, -1, 0, 1, right? Now, but if I told you to graph this function down here, what would we do to our y values? Okay, well, let's rewrite this real quick. Let's rewrite this like we're used to seeing them. Usually we don't see this 8.5 here at the front, right? So this is the same thing as -8.5 cosine of 240 pi t, and then we would put that as plus 8.5. Remember when we were doing our tables? What would affect our y values here? The two numbers on the outside. So what would we do first? Would we multiply or do we add first when we're dealing with y? We multiply first. So we would multiply by -8.5. So if I do that, what is that going to give me for my range? Yeah, 8.5 to -8.5. We always put the smaller number first. And then what would we do? We would add that 8.5 at the end, wouldn't we? And so if I add 8.5 to those, what is that going to do? It's going to take it to 0. To 17, isn't it? So that right there is my maximum wattage. Now I just did it out of the table form, okay? We could have taken the table, just like what we did when we graphed them, and said, well, x we're going to do whatever with, okay? We could have said we're going to divide by the 240 pi, which we don't need our x's because we need to know that p value, which is our y value, okay? And we could have said our y's, we're going to multiply by that -8.5, and then we're going to add 8.5. And we'd have seen in here our smallest number would be 0, and our largest number would be 17. And pull it from there if you wanted to. All right, so now we know that 17 is our maximum wattage. So that's my maximum P. So now can we find the wattage rating? All right. I'm going to erase some of what I have over here on the left so that I have room to write it out. All right, so to find your wattage rating, you know it's 1 over the square root of 2 times that maximum P. So it's 1 over the square root of 2 times what? 17. And what is that approximately? Anybody got a calculator? All right, so we put that in our calculator. And what did you get?
I got 12.
I did too. So 12 watts.